So about 10 days ago, I uploaded my wave-particle duality solution. And as hypothetical as that video is, and all of my ideas, it got me thinking when I scrolled past a TikTok that was talking about Hawking radiation. And I wondered if there could be some parallels to the particles that emerge from Hawking radiation and the particles that emerge from the double slit experiment. So in my video last week, basically I was saying that measurement is a trigger for non-local retrocausality, and that trigger causes local causality, or the particle that we see when we make a measurement. I used a reverse raindrop example, and it was our measurements that non-locally caused the excitation, the water to converge. So it's like time going backwards, so the water droplet would come after the excitation is made from the wave originally, and then the particle will fly up, and that is what the effect is when we measure a particle. So it is a retrocausal interaction. Black holes have a horizon. What if measurement itself is a horizon of causality based off of Heisenberg's uncertainty principle? The detector isn't just a measuring device. It is literally the point where non-local information becomes local reality. This is the boundary condition that necessitates the particle's emergence. This is a type of imminent future for the particle that we observe. So we could possibly say that the particle that we detect is the singularity of this excitation of non-local convergence. In contrast, a black hole's immense gravity at the event horizon separates virtual particles and real particles that emerge from that horizon. So what I find really interesting is that the real particle that we see as Hawking radiation emerges from the event horizon outside the black hole, but the real particle that we see when we make a measurement comes from that singularity. And so it's like looking inside a black hole. This reality that we see is local. We don't see non-local reality. We don't see non-local reality because the position is spread out. It is non-local, and it's in its natural wave-like state. It's like our measurement triggers the quantum fluctuations outside, but what we see instead of Hawking radiation is what fell inside, and the particle that fell in is the local detection of the particle that we planned to measure. If we could see the non-local information, then when we make a measurement, would there be a type of Hawking radiation non-locally? So, a photon would emerge, and we would see non-locally a horizon of light for the particle that we've measured locally. But we don't see that. We see the other side, what fell in. Now, I might be tripping, but it seems like we are seeing two different types of realities. We're seeing the reality outside a black hole, and we're seeing the reality of a singularity of information. And I feel like there are some heavy parallels between these two, the measurement and the event horizon of a black hole, and how we may be triggering. We might literally be causing quantum fluctuations around a type of event horizon of information of that non-local particle to create the excitation of locality. particle that we measure, which is the effect of our measurement.